We are in Nocona, Texas.
And we are watching an ICF house being poured.
ICF stands for Insulated Concrete Forms. Here's what they look like.
They're kind of like Lego.
They even call them blocks, and they sort of snap together. It's really a friction fit. You can build all sorts of things with them: houses, offices, multi-story buildings, hospitals, and more. The white parts of each block is expanded polystyrene. They are held together by injected molded polypropylene ties that are super strong. The walls of the building get assembled by stacking the blocks according to the building plans. The house being poured today just uses them for exterior walls, but some plans use them for some interior walls too. Different width blocks are available for different wall thicknesses. The forms also come in a variety of shapes to accommodate a wide multitude of designs.
I told you they were like Lego.
One way they are different than Lego is they are reinforced with rebar when they are stacked, and once they are all in place, they are filled with concrete. The end result is a wall with insulation on the inside and out, and reinforced concrete sandwiched in between. The black ties that held the blocks together now serve as anchors that you can screw directly into, making the walls ready for exterior and interior finishes like sheetrock, siding, and brick. There are tons of advantages of ICF construction, but we'll save that for the end of the video.
The concrete pour is what we are here to see.
First, let's look at some pre-pour footage to help get you oriented to what is going on. They start laying blocks at the corners. Each layer of blocks is called a course. Like on a brick wall, the seams between the blocks are staggered on each course. To keep things square and snug, metal bar latches or clips lock the blocks together in the bottom courses and the top courses. The length of most walls doesn't match up exactly for a whole number of blocks, so adjustments have to be made. It is possible to reform the blocks to an exact length, but the more common way to do it is what you see here. A seam is created by cutting the blocks flush, and it will be reinforced and sealed with wood prior to pouring. The slab was poured with regularly spaced rebar stubs along the wall center lines. Horizontal rebar is attached to those stubs like you see here. Additional horizontal rebar is tied in every other course of blocks. More horizontal rebar is regularly placed from the floor to the full wall height. Windows are framed out with wood forms and wood sills with long exposed coated screws that will anchor into the concrete. The spans above the windows get even more horizontal rebar, providing them with additional support. After all the walls are up, additional preparation is made for the concrete pour. This footage is from the night before the pour. First of all, notice that the wood reinforcements for the vertical seams are in place. And when you look at the windows, you will see additional bracing to support the concrete while it sets. You'll also see scaffolding that runs the full interior perimeter of the home. This is where the crew will stand to control the concrete flow from a pumper truck. There's also spray foam used to seal around windows and any other potential leak points. Everything looked ready for the pour, and the sun was getting ready to set.
So we headed down into town for some enchiladas and a good night rest. The next morning, I wanted to be there before any trucks arrived, but Dad stopped for donuts, so the pumper truck beat us.
We still got there in time to see him set up, though. The pump truck operator had to get set up before the concrete trucks arrived. Part of this meant finding the best place to park his truck. His boom is 117 feet, and the far corner of the house is 112 feet from the crushed rock pad, so he had to snuggle that truck right up to the house. He had to leave room for his outriggers, though. These gave him a wider base to operate from, and that is super important. That 117-foot boom is heavy.
And heavier still with concrete flowing through it.
Without a wide, stable base, the truck and boom would tip over, and that would make for a bad day. He also had to hook up hoses, prep the truck, check the pour pattern, and maybe most importantly, test the full extension of the boom to make sure that that far corner would be reached.
It did reach, but it was a good thing that that corner wasn't another 2 feet away, or I would have been shoveling concrete.
While the pump truck operator was getting ready and conferring with the crew boss, the rest of the crew was making last-minute checks and preparations. They wanted everything in place and ready once the concrete started flowing. That included things like final wall inspections, getting equipment set out, and putting down cardboard to catch splatter. Wall penetrations were put in place for exterior hydrants. Their timing was pretty good because just as they were ready, the first concrete truck showed up. After the crew chief inspected the concrete and slump tested it, the pour was underway. Concrete slides down this chute into a hopper on the pumper truck. A valve flips between 2 hydraulic pistons that cycle, sucking the concrete into tubes or pushing it out of the tube into the boom. Starting at the right side of the garage, concrete was pumped in. Crew members handled the hose and communicated with the pump truck operator to move the boom or when to stop or start flow. The operator could do this by remote control.
He could even honk his horn remotely to let the concrete truck operator know when to stop pouring concrete into the pump truck.
The full wall height doesn't get poured all at once. It gets poured in about 3 layers. The first layer goes about 2 to 3 courses high. Pouring it in layers does a couple of important things. First, it's easier to prevent any voids in the pour. We want solid concrete and no air pockets. Next, pouring it this way gives the bottom layer time to start hardening, making it capable of supporting the weight of subsequent layers. Too much weight all at once on the forms would risk a potential blowout, especially at seam points. The layering effect avoids that. The windows give a good look at how well the concrete flows. You can see it moving through the forms freely and filling up the walls evenly. And here's a good look at the windowsill screws we talked about earlier, soon to be concrete anchors. Not only was the concrete flowing smoothly, so was the whole process.
Under that wall? There is no way to do that. Okay. Look, poquito más. Poquito más. A little more. A little more. Okay.
We ate donuts and watched as more concrete trucks showed up and the crew kept layering the walls. It took 5 concrete trucks for this pour.
When the last of the concrete was poured, the top was leveled off and smoothed. Then J-bolts were inserted along the top of the wall to finish it off. Now, it just needed a cure. Once it does, construction can continue. Chases for pipes and electrical work can be cut into the insulation layer of the blocks. Wall finishes can be attached directly to the blocks thanks to the black polypropylene fastening strips embedded into the block forms. You may wonder how the finishing crew knows where these strips are. Fox Blocks made it easy by forming these identification markings directly into the block. Where this strip is on the outside of the block is where the fastening strip is embedded.
And when construction is done, this home will enjoy several benefits.
ICF construction cost can be more expensive than traditional stick frame, but that extra upfront cost will pay long-term dividends. First of all, the walls are very strong. They can withstand up to 250 mile-per-hour hurricane winds, tornadoes, earthquakes, and are fire-resistant for up to 4 hours. This can make insurance premiums cheaper. But perhaps the most touted advantage is their insulating properties. With an R value of more than 23.5, the energy savings is significant. That is a nice feature anywhere, but especially in a place like Nocona, where the summer electrical bills can soar.
Hey, it gets plenty cold here sometimes, too.
Yes, the energy savings is a year-round thing. Those thick, well-insulated walls have another advantage too. They make it quieter inside. And being a much more airtight house than conventional construction means less dust and fewer allergens. The end result is a well-performing home that will be around a long time. Special thanks to Whitworth Construction for letting us watch and ask so many questions and sharing some of their footage of the concrete pour.
I hope you enjoyed this video and learned a lot. We sure enjoyed making it and learning along the way. Thanks and see you next time.